Okay, hello class. I hope everybody's doing well. Today is Tuesday, April the 7th, and we are going to be starting covalent bonding because hopefully you finished your ionic compound naming sheet and submitted it through Google Classroom. It's due tomorrow. Okay, so we're going to start off with covalent molecules today. Our goal is to know how to name them, to know their properties, and we are going to introduce drawing them today as well. So hopefully you've printed off the PowerPoint and the sheet that says steps for drawing, because you are going to have to follow along my example when I'm drawing the molecules. Okay, so let's get started. So what are the big ideas? The nature of attractive forces that exist between particles in a substance determine the properties of that substance. So technological devices that are based on the principles of atomic and molecular structures can have societal benefits and costs. So again, what are our learning goals for today? We want to understand how covalent bonding works. We want to be able to apply steps, which is on a separate worksheet for you to print out, for drawing the Lewis structures, to be able to visually represent various molecules. And then we're going to talk about exceptions to the octet rule when drawing. Okay, so let's recall a bit from our last lesson. What is an ionic bond? So an ionic bond is a chemical bond between oppositely charged ions, and an ionic compound forms between a positively charged metal, which has lost an electron, and a negatively charged nonmetal, which has gained an electron. So example is sodium chloride. Sodium is a metal and chlorine is a nonmetal that's supposed to be a small L there, and they come together to form an ionic bond. So the electrostatic attraction between the positively charged sodium ions and negatively charged chloride ions creates this very strong crystal lattice structure, which looks like this. Okay, and they have very high melting and boiling points because it's really hard to break these apart. Okay, so let's talk about molecular compounds now that we've recalled ionic. So just an introduction here, nitrous oxide, N2O, is what it composes laughing gas. So if you've ever had like a dental surgery and they've asked you, do you want laughing gas? It's made up of N2O. And it's used by dentists to relax patients. However, a similar compound, nitrogen dioxide, which is NO2, it's just differing by the number of N's and the number of O's, is a toxic gas emitted by cars. So both are molecular compounds, and it's just amazing how if you just differ by one N and one O, it's like a completely different molecule. So what is a molecular compound? It's a pure substance formed from two or more nonmetals, chemically combined. So a molecule is a particle in which atoms are joined by covalent or molecular bonds by sharing. What is a lone pair? It's a pair of valence electrons not involved in bonding. What is a diatomic molecule? It's a molecule consisting of only two atoms of the same or different elements. In this case, we say they're the same. So you have to memorize this acronym called Hofbrinkel right here in the balloons here. So this is just representing all the atoms that exist in pairs in nature. So they do not exist by themselves. So if I ever told you hydrogen, H, it's always H2. Oxygen, O, is always O2. Fluorine, F, is always F2. Bromine, Br, is always Br2. Iodine, I, is always I2. Nitrogen is always N2. And chlorine is Cl, is always Cl2. Okay, and it's shown right here in this chart. Okay, so nonmetals all have almost full outer electron orbits. They have space to attract other electrons. So the difference between ionic and covalent is ionic actually one atom loses electrons and the other atom gains. In this case, in covalent, they do not do that, they share, okay? So here's an example. We have one hydrogen atom with one electron in its outer shell, another hydrogen atom with another electron in its outer shell. When they combine, they share their one electron, so that in total they both have 2. Another example is chlorine gas. They each have 7 electrons in their outer shell, but when they share, they are each happy or stable now, because when they share their 7 electrons in their outer shell, they each have 8. So let's count here. This one has 1, 2, 3, 4, 5, 6, 7, 8. This one here, if you count the electrons in its outer shell, 1, 2, 3, 4, 5, 6, 7, 8. So they're each happy now. So we represent when we bond 2 chlorines, and the 2 electrons here are bonded, we circle them right here. And then we represent that circled pair with a stick. So this stick represents a pair of electrons. So some other examples, and we're going to learn how to draw these through the steps I'm going to go over today. So here's CH4, which is methane gas, water, H2O, and ammonia, NH3. Okay, so now we're going to talk about naming, and there is a worksheet attached to this post, which you do have to go through and hand in through Google Classroom, just like you did with the ionic. So the names of molecular compounds, they have prefixes, which is different than ionic. These prefixes are used to count the number of atoms when the 2 elements are coming from different combinations. So for example, mono means 1. So for example, if we have CO, you would say carbon monoxide because there's 1 O. Di means 2. So in this case, CS2, you would say carbon disulfide. Tri is 3. So when you have SO3, you would say sulfur trioxide. Tetra is 4. So it'd be carbon tetrafluoride because it's CF4. And penta is 5. So in this case, PBr5, you would say phosphorus pentabromide. Okay, some exceptions. So some molecular compounds don't follow a naming system, and you just name them by their common names. So for example, when you look at hydrogen, 2 hydrogens with water, H2O, you don't say dihydrogen monoxide, you just say water. Okay. For NH3, you don't say nitrogen trihydride, you say ammonia. Okay. For hydrogen peroxide, H2O2, you just say it by its common name. Okay, and so on. Okay, sample problem number 1. Let's name this compound. So first you write the name of the first element. So P is just phosphorus. If there's just one phosphorus, you do not have to say monophosphorus for the first element. Okay, then we're going to write the name of the second element, replacing the ending with "ide." So in this case, there's 3 chlorines, so we're going to write trichloride. Okay, so the answer is phosphorus trichloride. So remember to refer to these sample problems as you're working through your worksheets. Okay, so here it says, remember you only need to use prefixes with molecular compounds, not ionic. So if you see 2 nonmetals, you know right away you're using prefixes. So let's do an example with writing chemical formula for molecular compounds using some set of rules here. So the prefix in the name becomes a subscript in the formula. It's a little bit easier than with ionic. So write the chemical formula for nitrogen dioxide. So this tells us that there's 1 nitrogen and how many oxygens are there. This prefix here tells us there's di, which means 2 oxygens. Okay, so we're going to write the symbol for each element. So nitrogen is N, oxygen is O. And then you write the prefix as a number after its element symbol as a subscript. So it would be NO2. Okay, and that's your answer there. Again, refer to the slide when you're doing your worksheet with finding formulas. Okay, let's practice. So CO is carbon monoxide, NCl3 is nitrogen trichloride, N2F4 is dinitrogen tetrafluoride because there's 4 fluorines here. P2O5 is diphosphorus pentaoxide. So notice here I didn't put the penta. When you have two vowels in a row, you can get rid of the A here. Sulfur pentafluoride is SF5. Dinitrogen monoxide, there would be two nitrogens and one oxygen. Carbon tetrachloride, there'd be one C and four Cls. Okay, so let's do a brief comparison of ionic versus molecular. So ionic are made up of cations, which are positive ions, and anions, which are negative ions, and molecular compounds are just made up of molecules. How are they bonded together? Ionic compounds, one metal loses and the non-metal gains, so there's an electron transfer. Whereas in molecular, you're sharing. The forces between the particles, very strong attractions between the ions, and strong repulsions between ions of like charge. For molecular, there's strong bonds between the atoms, but weak attractions between the different molecules. Elements present in ionic, metal and nonmetal. In molecular, just nonmetals. Electrical conductivity, very good when melted or dissolved, and for molecular, it's poor. So you can refer to this chart when we do our virtual lab comparing ionic and molecular compounds. The state at room temperature is solid, so usually they're metal, so they're solid. And for molecular, they can exist in all three states, depending on what you're looking at. Melting and boiling points, like we said before, very high for ionic and low for molecular. And other names, you can say salts for ionic or covalent compounds for molecular. Okay, so remember the octet rule. Atoms form the most stable substance when they are surrounded by 8 electrons in their valence shell. That's what makes them stable and happy. That's why atoms bond. Okay, so we are now going to go to the second video. I'm going to walk you through the steps on how to draw some simple molecules. And we're going to touch more on this after the Easter long weekend on Tuesday. Okay, so we're going to stop here at slide number 19 and make sure you complete your molecular compounds worksheet for naming and some practice questions, which I'm going to go over in the next video. Okay? Okay, have a great day, and we'll see you on Zoom on Thursday. I will be sharing the link for that soon.